Welcome to yet another session on data engineering. In our last session, we saw how we can capture the streaming data from sensors using IoT Hub and push it to a data lake using Stream Analytics job. We could also see how this data could be downloaded as a CSV file from the data lake. Now, in this session, what we're going to see is how we can get this data from the data lake and visualize the same data in Power BI. So what I have is a screen, the opening screen of Power BI. If you're not familiar with Power BI, I'll suggest that you watch my series of videos on Power BI, where I have spoken about the basics of using Power BI. So we are going to take this data from the CSV file and visualize this in Power BI using some useful charts. Uh, Obviously, the data that we are going to visualize is a static data because we have taken the data for a particular period of time and downloaded it in the form of CSV. And some cases, this is very, very important, especially if you're trying to do some descriptive analytics. However, in a subsequent session, I'm going to talk about how you can visualize real-time data as the data is getting captured, how you can picturize how the temperature is moving or how the humidity is moving directly in Power BI. But this session is for visualizing the static data. So let us first get the data. I have already saved the data as a CSV file. So I will get the data as a CSV file. Wherever I have saved, you can pick it up from the directory that we have saved the file. So you can see that I have picked up the data from the folder where it contained the data. Now, the first thing is that we need to transform the data and check the data types and any other changes that we think are necessary. So we'll go to the Power Query Editor, which is again another tool for use for data transformation. If you're not familiar with this, again, you can watch some my earlier videos on Power BI where I have discussed in as an overview the use of Power Query Editor. So we'll go to the transform data. If we want, we can directly load the data from here, but we think that we might need some transformations. So we'll go to the transform data. Power Query Editor screen will open up. The first thing that we need to check is whether our data types are correct. So here, if you see, this is the symbol of the data type. So device ID is message ID, for example, is a numeric value. Device ID is a textual value, which is fine. We have only one device here, so the device ID is same. Temperature and humidity are numeric values, are floats, so which is also fine. What you need to check especially is the event process date and time. Okay, the event process time and event enqueued time. We may not be using the enqueued time because it is a time when the event was queued, and this is a time when the event actually happened. So we'll be using this event queued time, process time for our charts, but we can leave it for any information purpose. And then again, the IoT Hub, it just says whether it's a record or not. So essentially, the three fields that are relevant for us is temperature, humidity, and the event process UTC time. Okay. As of now, it appears that the data is clean and we can use this data for visualization. We do not need any further pre-processing. So we can just close and apply. In case you saw that these data types are different, then you might have to change it. But Power BI is usually intelligent enough to figure out which data type is required. So we'll just close and apply over here. So once we close and apply, we should be able to, the data is getting loaded inside Power BI as a table. We have to give some time for loading it into the table and is building what is called a data model. And the data model will be visible over here. Let it load. Just come back after the loading is complete. The data has now got loaded and you can see the data over here. You can see the model has come over here. In this particular case, there's only one table. So we have less of problem to worry about in terms of joining the table, etc. And this is the table view that we have. These are the data which we have imported from the CSV file. And now we are going to make the relevant charts. So this data is essentially a time series data. So for any time series data, the most appropriate chart is a line chart. So we'll make a line chart. So the first line chart we are going to make is, let's say, for temperature. So my x-axis will be the event process time. Now, in the event process time, you can see that there's a hierarchy of year, quarter, month, day, and time, but we don't need that hierarchy. What we need is the actual time. So we change this hierarchy and get the actual time. And in the y-axis, we will have the temperature. This data has only temperature, so it doesn't have the humidity. But if we captured humidity, we could have got that. And you can easily see that we have got the data of temperature. As you can see that this data is not evenly distributed. The reason for that is because we have set up a cloud environment and not an edge environment. So it does not evenly flowed in and the data has not evenly flowed in. And there are cases where the data has been missed. And this is a very common thing if you use a cloud environment in this kind of scenario. So typically for this type of scenario, it should be an edge environment where the data should be collected so that the data is evenly collected. We can have because it's temperature, let us color the lines in red instead of blue. Sense? Okay. And let us also identify the values against this. So we can put on the data level. And once I put on the data level, you have the temperature values over here. Okay. Now let's say we want to find out what is the average minimum line for this minimum temperature. You have this blue line coming up and blue color suits fine. Let's give the maximum temperature. Let's mark the maximum temperature with deep red. And let's have the median temperature or the average line maybe. Make this line as green. So you have a graph which gives me the temperature and this minimum and maximum. Let's see if we can make a forecast of this. I don't want to do it in the same chart, so I'm using another chart so that it doesn't get cluttered. And in this chart, I'll remove the minimum and maximum values so that it is not cluttered. And let's see if we can have a forecast. Now, as you can see, that is unable to give you a forecast because normally for a time series forecast, you need the data in equal intervals, and we don't have the data in equal intervals. That's why it is unable to give you the forecast. Later on in another session, we are going to see how we can use a Python um, uh, code to inject artificial data and make it a continuous set of values in equal intervals and then forecast the data. But this data by itself, it is not able to give any forecast because the data is not evenly captured. And why is the data not evenly captured? We said that because we are using a cloud environment and not an edge environment. Let us see if we can find out some anomalies. Again, make it in a different graph. Remove the forecast. Trying to see if there are any anomalies. If there are any anomalies, it will point out the anomalies. As of now, it is not finding any anomaly. It may also be because of the fact that it is not able to forecast. Okay, if it is a evenly spread data, then it will be able to forecast. Let us now make a gauge chart. The gauge chart, and the value that we want is the temperature. Now, we don't want the sum of temperature because each individual point we want to have a temperature and we want to see where the temperature lies as an average. Okay, and let's say so we will not use a sum. Instead, we'll use an average, and so we could have given a minimum and maximum value and a target value. Target value will give, but minimum maximum value we could have given. But if we do not give any value, then it will take the minimum and the maximum value in that range, like it has found minimum to be 0 and the maximum to be 50.43, and it will make a gauge according to that. But we need a target value. Let's say our target temperature is 20 degrees Celsius. So what we need to do, we need to create a new measure called target temperature. We'll create a new measure. 20, let's say. And now this target temperature is a part of my data. I can go back in the chart and put this target temperature in my target value. So you see the target temperature line over here. Now what I can do, I can also change this color based on the uh, temperature that I'm getting. If the temperature is, let's say, less than 15, then it should be blue. If the temperature is between 15 to 35, it should be yellow, and if the, or maybe green. And if the temperature is more than 35, it should be red. So how do I do that? I go over here, and in the colors, I write a function. So this target color, you can see the deep blue color is coming over here, but the fill color, I want to change based on the range of temperature where the current temperature is located, the average temperature is located. So we go to the function, and in the function, I can use the gradient, and I can say that if the value is uh, less than uh, 10, then I would use a deep blue and add a middle color. If the temperature is, let's say, between 10 and 35, I'll use a green. And if the temperature is more than 35, I'll use a red. But red. So this is my color range. Now, if I make this, you see right now my fill color is green because it is lying in between 10 and 35. So that way I can make a very simple gauge chart using this. So hopefully we have been able to understand how we can use the static data and use it for the purpose of visualization. In the next session, we are going to see how we can use the streaming data and create live charts in Power BI.